Welcome to the third lecture of the course on wireless networking. In our previous lecture, we noted that an IoT device has four components and tasks. In the previous lecture, we examined computation, and the focus of this course is on wireless networking. In this lecture, we are going to discuss sensing and actuation. These tasks can be considered eyes and hands of IoT device, and these tasks allow IoT device to interact with the physical world. So sensors and actuators play a very crucial role in the functioning of IoT devices. They allow these IoT devices to perceive and interact with the world, and sensors serve as the IoT device's eye. They collect data from the environment and send this collected data to a processor for understanding the environment. On the other hand, a device's actuator act as its hands, and it allows it to manipulate and influence the physical world. For example, an actuator like a motor allow devices such as robots to move around in the environment. Sensors and actuators work together to make IoT devices intelligent, allowing them to respond to changing conditions and interact with the world in a meaningful way. Let's begin by discussing actuators. They are a very crucial component in IoT devices and allow them to modify physical quantities and interact with the environment. Actuators come in various types and size, and each of them have their very unique function. Some of the common type of actuator includes light or LEDs, and they emit electromagnetic radiation in the light spectrum and helps us provide a visual representation of the world. Motors, they allow IoT devices to move and physically interact with the surroundings. Speakers, they generate acoustic signals and allowing IoT devices to communicate in the auditory domain. It is very important to note that the choice of actuator depends upon the specific task that the IoT device is designed to perform and the environment in which it will operate. As a result, each type of actuator has its own advantage and disadvantage, and selecting the appropriate actuator will play a key role in determining the overall performance and effectiveness of the device. We should also note that typically actuation is a power-consuming task when compared to sensing and computation. So one of the actuators is that you are going to use in this course, including in the first assignment, is a light emitting diode. So light emitting diodes are a directional component that allow current to flow in one direction, and as the current flows through this diode, it produces light in the optical domain. So LED typically can look like the representation on the slide, and the shorter side of the LED is usually the cathode. And LEDs are a very effective way to indicate the status of the device and provide feedback during the development and the testing phase of IoT device. We had talked about in the previous slide that printing out statements from IoT device could be power consuming and can also cause timing issues. And one way to debug applications written for IoT devices is by blinking LEDs. You could blink LED to indicate which part of the code your application is currently in. One of the unique variant of LED is something called RGB LEDs. RGB stands for red, green, and blue. And these LEDs allow emission of light in 3 different colors. The short LED is usually typically the negative end, and each color in the RGB LED has a separate wire. And by combining signals on multiple wires, a range of colors can be emitted by RGB LEDs. RGB LEDs provide a very efficient and versatile way to add color to IoT applications, as well as they can support lighting applications. For example, you could have RGB LEDs in your house and control the color of the light emitted by these LEDs. Thus, by controlling the intensity of each color through the amount of current that is flowing through the LED, a wide range of hues and shades can be generated using these LEDs. So we are going to use sensor tags in this course. So what are the actuators on these sensor tags? So sensor tags comes with several actuators. It has LEDs that we are going to blink in the first assignment. It also has a buzzer that can allow you to make noise through the sensor tag platform. So next, let's look at what are sensors. Sensors enable the measurement of physical phenomena and play a crucial role in the functioning of IoT device. They come in various shapes and size and allow IoT devices to perceive the physical world. Over the past decades, we find that the sensors have gone a significant advancement and they have become low power, capable, and versatile. As a result, sensors are often the lowest power consuming component in a typical IoT device. Consequently, because of all of these features, sensors have seen a very widespread adoption and usage, and they're used in various applications from environmental monitoring to industrial automation to healthcare and well-being sensing. So just to give an example, Apple launched one of their latest iteration of their watch couple of months back. And one of the bigger marketing and the selling point of this watch was that it had a temperature sensor built in. And this allowed this Apple Watch to keep track of your body temperature. Thus, sensors have essentially become an important part of almost all consumer electronic devices. So let's look at the two different sensing modality. And these are active and passive. So active sensors emit an electromagnetic energy, which is then reflected by the environment. And then this energy emitted by the sensor can be captured by back as it is reflected by the objects present in the environment. And this reflected signal allows these sensors to gather information about its surrounding. On the other hand, a passive sensor does not emit electromagnetic energy, but instead gets information by collecting the energy reflected by the physical objects from the ambient energy that are all around us. For example, the first image is an example of passive sensing. Here, the sun generates electromagnetic energy, which is reflected by the earth, which is then captured by a satellite. However, in the second image, we have the satellite generating electromagnetic energy, for example, radio wave signals, which are then reflected by the earth, and these reflected signals are captured by the satellite. Since the satellite is generating these electromagnetic energy signals, that's why it is called active sensing. So typically the example of active sensing includes, for example, things like flash photography, ultrasonic sensors, lidar, and we are going to talk about active sensing over the next few slides. But we should also note that typically for the IoT devices, passive sensing is the preferred method. And this is because passive sensing is typically lower in power consumption. The passive sensors are cheaper. And the reason is that they are not generating electromagnetic signals that are radiated by the passive sensor. So let's talk about the first active sensor, which is an ultrasonic sensor. Ultrasonic sensors are a type of active sensors that utilize piezoelectric transducers to convert electric signal into sound waves. So these piezoelectric transducers take electric signal and converts into the acoustic signal and that are radiated out by the ultrasonic sensor. The typical construction of an ultrasonic sensor, as we show on the slide, includes two or more transducers, where one of the transducer acts like a transmitter, and the other transducer acts like a receiver for the reflected signals from the physical objects present in the environment. So the basic operation of an ultrasonic sensor involves emitting a high frequency sound waves, which are not audible to humans, and measuring the time difference between the emission and the reception of the reflected sound wave at the ultrasonic sensor. And the time difference can be used to estimate, for example, the distance of an obstacle from the sensor. However, as we had mentioned in the previous slide, that the actuation can consume significant amount of power. As a result, ultrasonic sensor typically consume few milliwatts to several tens of milliwatts of power consumption. And these ultrasonic sensors are widely used in various applications, including, for example, robotics, or for example, detecting the level of water in a tank, or other such obstacle detection applications, including, for example, things like in automobiles. So let's examine another type of active sensor. In present day, we have, for example, robotic vacuum cleaners that can map the environment, navigate, and clean our homes. These vacuum cleaners are equipped with multitude of different sensors. So what kind of sensors do these vacuum cleaners utilize to create a map of the environment? So your vacuum cleaner is very likely to use a sensor that is called lidar. Lidar stands for light detection and ranging. And lidar is a technology that is utilized for mapping the environment, and it is a form of an active sensor. So the lidar sensors operate by emitting laser pulses, which then bounce off the objects in the environment. And the lidar sensor then measures the time taken for these pulses to bounce off the objects. And this time scale could be at the order of nanoseconds. And by calculating the difference in the time between the transmitted and the reflected pulses, the lidar sensor can estimate the distance of the objects from the environment. The lidar technology has a wide range of application, including creating detailed maps of the environment, including for archaeological purposes. It is also used for self-driving cars, robotics, vacuum cleaners, and many other such applications. However, we should also note that the lidar transmitter and receivers can be complex and sophisticated, and transmitting laser pulses can consume significant amount of power. As a result, currently, these sensors are typically power intensive and not often used on IoT devices. But with the rapid miniaturization and the development of technology, we can expect that in the coming years, lidar might also be actively used on IoT devices. So with this, we conclude the first part of the lecture 3.